Hello, everyone. Welcome to this talk, workshop, deep dive. Today we are going to talk about Istio Service Mesh and how to do Java microservices on Kubernetes with Istio Service Mesh. So I'm going to be sitting. It's going to be close to 3 hours. Short introduction. My name is sasidharan. I'm the co-lead of JHipster. I'm also a Java champion. I created a bunch of OSS tools, including K-Dash, JDL Studio, and stuff like that. I'm an open source aficionado, polyglot dev, author speaker, so on. I work at Okta, focusing on the Auth0 platform. So please follow me on my socials if you are interested in the content that I'm talking about. So let's get on with it. So first, let's see what Istio is, right? So Istio is a service mesh for distributed application architectures, right? Especially the ones that you might run on Kubernetes. So Istio plays really nice with Kubernetes, so nice that you might think that it's part of the platform. And some of the, I think a lot of cloud providers also kind of support Istio out of the box, like Google Cloud supports Istio out of the box. It's well integrated. Istio isn't the only service mesh around. We also have Linkerd, we also have Console, which you can also use as a service mesh. So there are multiple options, but Istio is one of the popular ones. So what exactly does Istio do? So a service mesh provides features to help with common distributed application challenges or microservice challenges, right? Like service discovery, routing, load balancing, and so on. And Istio specifically provides secure service-to-service communication over TLS. Of course, it has support for identity, authentication, authorization, these kind of things. You can integrate different identity mechanisms. It has basic service discovery that works very well together with Kubernetes or Console, depending on which platform you're using Istio with. So it helps your microservices to discover each other. It has automatic load balancing. It has traffic control features like routing, circuit breaking, retries, failovers, fault injection, and so on. Like whatever you could think of in a microservice architecture, Istio would have some kind of support for that. It has a pluggable policy layer, which you can use to do things like access control, rate limiting, A/B testing, canary rollouts, and so on. It also provides automatic metrics, logs, and a lot of telemetry for all the traffic within the mesh. And it also provides ingress and egress controllers. So these are the features that Istio offers. So let's take a quick look at the Istio architecture itself. So the architecture is divided into two planes. That's how Istio kind of categorizes them. So there is the control plane and the data plane. So the control plane, it consists of the Istio daemon. And the Istio daemon manages and configures the envoy proxies on the data plane for to route traffic. The control plane also enforces policies and collects telemetry. Previously, it used to have separate components called Pilot, Citadel, and Galley, but in the newer versions, the Istio daemon integrates all these components and runs as a single service. So Pilot, the Pilot component is used for service discovery, Citadel component for security, and Galley for configuration management, which all now encompasses inside the Istio daemon. The control plane technically also consists of the Istio agent, though technically it runs on per port basis. It doesn't run on the control plane itself. So it runs on the ports. And then we have the data plane. So the data plane is entirely made up of envoy proxies. And envoy is a very high performance proxy. It's written in C, C++. It's lightweight and distributed. So it controls all the incoming and outgoing traffic that is coming, that is coming to your mesh, as well as the traffic within the mesh. And of course, since Istio collects a lot of telemetry, it configures a lot of telemetry, we can also use tools like Grafana, Prometheus, Keali, and Zipkin to kind of monitor and observe our setup or the cluster or the mesh itself, right? And all these tools works out of the box with Istio based on the Istio profile that you're using, of course. We'll see more about this later. We'll see some samples. We'll do some deployments with those. So we'll deep dive into those. So first we need a cluster, right? So I'm using the Google Kubernetes engine today, and if any of you are trying to follow along, so it might be good to have a cluster. From trying out different PaaS providers and different Kubernetes distributions, I find that GCP has one of the most smoothest in terms of using Istio. In other PaaS providers like AWS or Azure, you might have to fiddle around a little bit more to get some stuff working, whereas in Google Cloud, it works out of the box quite nicely. So these are the commands that I use to create the cluster. I already created the cluster because it takes a while. So I already have this cluster set up. I have 4 nodes on the cluster. It's on GKE. So if you're trying to create a cluster, it's quite important to note the num nodes and the machine type because for the demo that I'm going to show, you need at least 4 nodes and you need a bigger CPU type because of all the resource limits and stuff. So you can use these commands if you want to create this cluster. Once you have created the cluster, you can run kubectl config current context in order to, you can run kubectl config current context to check if everything is set up properly, if your current context is the cluster that you created. If not, you can use the gcloud container clusters get credentials command to set that up. So this is a prerequisite in order to proceed further if you are following along, of course. So yeah, we saw the cluster. So the next step would be to install Istio to our cluster. So from here onwards, this should be generic, right? This should be platform agnostic in the sense it should work regardless of what Kubernetes platform you're using. So I'm just using GKE, but if you're using something else, these steps should also work for that. So let's install Istio. Okay, I'm gonna. I'm using the latest Istio version 1.15. I probably already have it here, but still. I think probably I already have it. I'm just going to go into that. I already have 1.15 installed, so I didn't download it again. Seems a bit slow. And you need to set the path as well to use the CTL, the CLI from Istio. So that's it for the setup of Istio. So once you have run the curl command, it should download Istio, it should set up everything, and once you have put that in the path, you should have Istio CTL. So you should have Istio CTL running, and then we should be able to use you can use Istio CTL to install different profiles. So Istio out of the box comes with certain profiles. So you have a demo profile, which has all the telemetry stuff configured well. So it's nice to try out and play around and see what Istio can do. You could also install the production or development profile from Istio. They also have a default profile. So based on your needs, you can pick and choose. And Istio has a very nice documentation page where they explain what each profile does and what each profile contains. So you can choose based on that. But of course, for a demo, I'm going to use the demo profile. So Istio CTL install demo. So, and if we go back to our pods, you can see, let's look at the Istio namespace. So you can see that Istio D is being created, and soon it will create a few more stuff. I think by default, it's going to create Istio the daemon, which takes care of all the control plane stuff, and it will install the agent that is that's on a per pod basis, and it's also going to deploy the ingress and egress gateways. Of course, if you play around with the profiles, you can choose not to install the egress gateway. If you're not doing any outbound traffic from your mesh, you can ignore the egress gateway. Of course, you would need an ingress gateway to get traffic into your clusters or into your mesh. So the installation is done and everything is running. One more thing we would need is we would need the ingress IP. It would be required later for the demo. So let's make a note of the ingress IP. So you can do that using kubectl, or you can use whatever dashboard you're using to get those as well. So our IP, so we need the external IP. Okay, so this is the IP. I'm going to copy the IP for later. Next step would be, so we have installed the core components of Istio itself. So since we are going to try it out and we're going to demo this, we could also go ahead and install the charts for Grafana, Prometheus, and the observability stack that Istio provides. So so we are already in the Istio folder here. So what we can do is kubectl apply samples. So these are all the add-ons that we are going to install. So Istio provides some of the first-class add-ons that you can find directly under the add-ons folder, and there are also extras that you can find within a subfolder, like Zipkin and stuff. There are also other tools you can choose to install. So I'm only going to install Grafana, Prometheus, Kiali, and Zipkin. So let's do that. They are also going to be deployed in the Istio system namespace, so we should be seeing it in our Kubernetes pods. So the containers are being created. So I have Kdash running here. It's a Kubernetes dashboard tool I wrote in Rust. You can also use KNNS or any other Kubernetes dashboards, or you can just use kubectl to check these as well. I just find it convenient to have it running. So we have our Prometheus, Zipkin, and Grafana, and Kiali also running. So we are ready for that. So we have our Istio stuff ready, right? So next would be an application. And how can we create some microservices quickly or bootstrap a demo application quickly, right? Of course, I'm going to use JHipster. No point in trying something else for me, especially. So quickly about JHipster. Anybody here who have used JHipster or who is familiar with JHipster? Hey, I see hands. Nice, feels nice. Okay, cool. So I'm going to brag about JHipster a bit since I co-lead the project. So JHipster is one of the most popular rapid application development platforms for Java. Quite popular on GitHub and everything. Around 40,000 projects generated every month. Probably half of them are demo projects like these. We have a lot of contributors, a lot of installations, and a lot of cool numbers, plugins, etc. So what you can do with JHipster? So you can use JHipster to generate simple monolith web applications. You can use it to generate complete microservice architectures, like what I'm going to do today. You can also generate domain models, your JPA-ish entities and stuff. You can generate CI/CD pipelines and deployment configurations for Kubernetes, Docker, OpenShift, and so on. You can deploy to cloud or containers using that, and a lot more. To cover everything that JHipster can do would require a separate deep dive, so I'm not going to try or go into that because this deep dive is all about Istio. Of course, JHipster also provides very nice developer experience and very good code quality. This is our Sonar ratings. So it has quite good Sonar ratings, which means quite good, which doesn't mean quite good, but quite good quality, code quality. So enough talk. Let's quickly build a microservice architecture. for an e-commerce application. So this is the architecture that I'm going to build today, or what I'm going to deploy to Istio today. So we have our Ingress Gateway that is going to take in all the external traffic. We have the Istio control plane, which is going to take care of discovery, routing, and all those stuff that we talked about. We have four microservice applications. The first one is the store gateway. As the name suggests, it also acts as your gateway. So it hosts your UI. It kind of routes traffic to other services and so on. It has a React front end and a Spring Boot backend with a Postgres database. Then you have three microservices that provides REST APIs. So you have an invoice service, a notification service, and a product service. I just noticed that I put invoice for both. So one should be product. Okay, nice time to notice that. Yeah. So yeah, that's about the applications. And the microservices, they have their own database. Two of them have Postgres as well. Could have been anything, but doesn't really matter. One of them have MongoDB as a database. They all run in different ports, obviously. And we would be using the monitoring stack that we deploy to look at the telemetry that is being collected from the mesh. I mean, it's a, and if you notice that there is going to be envoy proxies, which are going to be attached to each of our service, as you can see. So the envoy proxies will be attached as sidecars to each of our services, so that it can kind of manage the traffic coming in and out of that pod. So it's not an overly complex architecture, but it's also not a very simple one. So I think it's good enough to kind of demonstrate what Istio can do. So in order to generate this application from scratch, you would need JHipster. So you can install JHipster using npm. One second. Yeah, you can install JHipster using npm, and then you can download this specific sample using the second command. If you don't want to use JHipster, if you just want to take the sample and try the Istio stuff, you can also just clone the repository that I have already created and use that. I'm using the JHipster, latest JHipster version. I already have it installed. So I'm just going to download and so I'm going to download this. Nope, not here. Here. Okay. So I'm downloading it. So this is what we have. We have an application. We have, so this is the gateway application being defined. I mean, quite straightforward, I would assume. I'm not going to go into details of this again. You can refer the JHipster documentation to learn more about the JDL format that I'm using. There's a reference documentation that you can check out, and the same JDL can be used. You can get the same JDL from the link shown here. You can also find more samples in the samples repository. So here we have a store gateway application. As you can see, the application type is gateway. We have JWT for authentication, Postgres, Hasselcast. We are using Gradle for build, and we have a React client side. And this is also going to kind of create the UI for all the entities. That's why we have the entities star here, because since it's a microservice architecture, JHipster would automatically know just to generate the UI for all the entities on the gateway, and all the REST APIs will be handled by separate microservices. Then we have the product microservice. It has 4 entities associated. As you can see, it doesn't have any client side or anything. It has a different port, very similar configuration otherwise. There is no service discovery here, because JHipster also supports using console or Eureka service discovery options. Since we are going to use Istio, we don't need service discovery. So I'm disabling service discovery on all the applications. Then we have our invoice application. Again, very similar, different ports and different entities. And finally, we have our notification microservice with MongoDB as database instead of Postgres, and just one entity. And then we have the entity definitions. So these are the individual entities. They are very JPA-ish definitions. I think they are quite straightforward for any Java developer. So you can do a lot with these configuration. You can define different types of fields, validation rules, and stuff like that. You can also have enums, and then you can also define relationship between your entities, very JPA-ish relationships. You can also generate service classes for entities, or you can choose to just use the Rust controllers and the repository layer directly, or you can have a service layer in between. That's up to you. You can create paginations for these, and so on. So similarly, we have the entities for product. We have the entities for invoice. And finally, we have the entities for notification. As you can see, we also kind of mark which microservice the entity belongs to, so that JHipster knows where to create the backend. And finally, we have a deployment configuration also defined. So with the deployment configuration, you can define Kubernetes deployments, OpenShift deployment, Docker deployment, and so on. Here, if you're downloading this and using, then you need to make some changes here. For example, you need your own Docker repo here, so that the generated files are using the right repository. And finally, you also need your Ingress IP. So I already copied the Ingress IP, so I'm going to put that here. So I'm using nib.io. Oh, this would have caused the demo to fail. Nice. So I'm using nib.io, which is a wildcard DNS service, just for demo purposes. Please don't use that for production. It is not safe. It's just for playing around and demo purpose, because wildcard DNS is not safe for production purposes. So the important aspects of this configuration is, of course, saying Istio true, so that it generates Istio configurations. It needs to have an ingress service type, and it needs to have an ingress domain. The ingress type GK really doesn't matter, because for Istio it's kind of ignored, so it really doesn't matter. Important aspect is the other three configurations. So with this single file, with JHipster, you can generate all the applications, the deployment models, and everything. So that's quite handy. We saw these. So finally, I think it's time to kind of generate this application. So I'm going to go here, and I'm going to run JHipster, JDL, and with the file. So it's going to take a minute or two, mostly because of NPM, because for the client application, NPM needs to download the internet. So that's going to take more time than building the backend and building the other applications. The applications are being generated in parallel, so it's going to be faster than creating them separately, of course. So let's see. So this would also generate the Kubernetes manifest, the Istio configurations, and everything. We'll take a look at that. But a bit later. So we'll go into the code, and we'll look through each configuration file and see what it means and everything. But first, let's have the application, and let's also run. Let's build the applications, and let's try to deploy them first and see a demo first. Then we go into the code, and we'll deep dive into the code. It's probably going to take a minute. So NPM, it's weird that these days NPM takes the most time in an application build, and not the backend build. So yes, we have everything. As you can see here, we have our applications. So it kind of generates a mono repo kind of setup. So we have our invoice application. We'll go into the code a little bit later. We have our Kubernetes configuration for all the applications, as you can see here, and also for the Istio stuff. We have notification, product, and store applications. So all our applications are ready. So let's kind of build them. So I'm going to use Gradle along with Jib. So Jib is a tool from Google that you can use with Maven or Gradle to make your Docker builds for your Java application faster, more efficient, and nicer to do without having to write any Docker files or Docker configurations. So you can just use Jib to do everything. So Docker JHipster already comes with that integration. So I'm using the bootjar command, and I'm going to directly specify the image that to be built. So I'm going to push the image as a store, and let's also build the other ones. So product. So I'm also going to build the product application, and then we build the other two as well. Okay, I'm going to build the other ones here just to speed it up. Oops. So the invoice is being built here. So product was built. So I'm going to build notifications here now. So the Gradle build is building the Java applications. It's packaging them as jar, and then it is building the Docker image and pushing it to my Docker repository in Docker Hub. So that's what's happening here. I think all our builds are done. So invoice done. Yes, and here a notification is built and store. So all our applications are built. So before we see the demo, we'll look at some of the code. So Istio Sidecar injection, that's very important if you're using Istio. So in order for Istio to work, we need to create a service mesh, right? And which means we need to add the envoy proxy as sidecar to our applications. So sidecar is a container added to a pod so that it can extend and enhance the main application that you're running in that pod. So in case of Istio, the envoy proxy sidecars manage the traffic that is coming in and going out of your container. So your container is kind of sandboxed with this proxy. So everything goes via the proxy. Sidecar can be injected either manually or automatically. So for manual injection, we can use kube inject command from the Istio CLI. It will modify the YAML files, your deployment manifest, before creating deployments, and adds the proxy as a sidecar with all the required arguments, containers, init containers, and annotations. So when you run the command, this is kind of the result that you would expect. Of course, there will be more, like in terms of arguments, commands, environment variables, and stuff. But the important aspects are it adds a container, which is the proxy itself, and it adds a init container with the same, which sets up the Istio init. So the init container is responsible for setting up the IP table rules and which intercepts the incoming and outgoing connections to the to your main application container. The Istio proxy container is the envoy proxy itself, which is the added to the container. So if you want to use manual sidecar injection, then you would always filter your Kubernetes deployments through Istio. So you would run this command against your deployment manifest first. You will save the output as your final deployment manifest, and then you will deploy those. So that is how you would do manual injection if you are doing. So let's try that out in one of our samples. So let's say Istio CTL. I think I'll use. Is it visible enough, or should I make it? Should I make the font larger to people at the back? Is it good? Larger, okay. Is it enough? Is it good? Awesome. Istio CTL, kube inject. Let's try the invoice deployment. I think I'm at the root folder, so I also need to put in the Kubernetes one here. Okay, invoice deployment. So this is just a deployment file that JHipster generated for the application. So let's look at the file first so that we know what changed. Invoice deployment. So I guess I should also make this a bit bigger. It's too big. So yeah, so this is the template that JHipster generated for one of the microservices. So it's a simple deployment. So you have your metadata, you have your spec, where we have replica selectors and the template itself. We have some pod affinities and stuff set up here. We have an init container with the busy box so that it waits for your database to start up first. Then we have the application container itself from my Docker repo. It's environment variables, resource pods, readiness props, liveness props, and stuff. So quite straightforward and simple, right? So now let's run this command, and it generates a new. It doesn't alter the file itself. It just prints out the output, so you can kind of save that to a new file or something so that you don't overwrite your existing. So you can see here, it still has the same stuff. The replicas, all this stays the same. It adds some annotations, some labels. It adds new labels. So all these annotations are from Istio. It adds new container stuff. So this is our existing container. Of course, the output kind of reorders your YAML stuff. I think they process the YAML and then output using some YAML process. So they kind of reorder the stuff, which is a bit annoying. I would have liked to see it in the same order as provided, but yeah, it's not a big deal. Then we have our new stuff added by Istio. So this is all new stuff added by Istio, the arguments, environments required, and the container itself. Where is it? Ports, readiness, prop resource, security context, volume mounts. Yeah, so this is for the Istio, the proxy itself, the envoy proxy itself. Trying to see the image, yeah. So you can see the image here. So this is the envoy proxy container being added as a sidecar. And then it also, of course, modifies the init container section to add the same so that it can set up the IP root tables and stuff like that. It also adds a little bit of whatever required for that. It adds everything required for that. So this is how you would do manual injection if you want to do it that way. So then there is also the automatic sidecar injection, which probably is more ideal if you are having an entire setup with Istio Service Mesh. Then you don't have to do this manually. But of course, if you are doing a migration, if you're moving to Istio from your existing setup, then probably manual sidecar injection would be something that you would start with, so that you exactly know what's happening, you have more control. But of course, it's if your entire architecture is running on the service mesh, then maybe it is useful to consider automatic sidecar injection so that your deployment manifest kind of stays pure with exactly what you put in there, and you don't have to worry about the Istio aspect. So for Istio sidecars to be automatically injected, so the injection happens at pod creation time using a feature in Kubernetes called the mutating webhook admission control. So unlike manual injection, the automatic injection occurs at pod level, whereas the manual injection happens at your deployment manifest level, so individual deployment level, whereas automatic is at the pod level. When you enable automatic injection, at the pod level, Istio uses the mutating webhook admission controller to kind of add these sidecars and all the data to your deployment. You won't see any changes to the deployment itself. Your deployment will show exactly the same. But if you check the individual pods using kubectl describe, you can see all the additional Istio stuff being added there. You can see the injected proxy as well. So this can be enabled using the kubectl label command. So it can be enabled either at the namespace level or at the deployment level as well. So you can do it using a label in your deployment manifest or just by running this command. So this is kind of how JHipster does it as well. So see, I'll show you that. So in the setup generated by JHipster, there is a simple kubectl apply script that it generates. I mean, it's nothing complex. It just prints out some useful information and it just runs kubectl apply for whatever we generated. And you can see here, it runs the kubectl label namespace command so that Istio injection is enabled, and it also says override true so that that aspect is overwritten if required, if it's already there. And we can verify this using this command. So we can run kubectl get namespace to see if the injection has happened, and we can see that it is not enabled on any of our namespaces yet because we haven't applied that script yet. We'll check this again once we apply it. So before that, let's deep dive into, before we look at the code and before we go through the code, let's understand a little bit more about Istio's traffic management and other capabilities so that it will be easier to explain the code and to kind of understand the code. So Istio has very powerful traffic management features. So you can do a lot with it. So like routing a certain percentage of your traffic to a specific version of the app. So you can kind of do A/B testing with that, or doing different load balancing policies for certain instances and services based on different conditions. You can configure Istio's traffic management APIs using Kubernetes custom resource definitions or Kubernetes CRDs. Istio provides a lot of Kubernetes CRDs out of the box, which you can use to configure all the aspects of traffic management, policies, authentication, service registry, and everything. So you can configure anything and everything in Istio using Kubernetes CRDs. So the first and the foremost important aspects of, or important CRDs that Istio provides are virtual services and destination rules. So virtual services and destination rules are the key building blocks of Istio's traffic management system. So virtual service lets you configure how requests are routed to a service within the mesh. So this is done using routing rules. You can use this to specify behavior for one or more host names, and you can send traffic to different versions of the same service or to entirely different services. You can do whatever you want. And without virtual services, Envoy will route traffic using a round-robin load balancing. So this is how you would set up A/B testing or canary rollouts, and things like that, using virtual services, and basically using combination of virtual services and destination rules is how you would achieve most of these features. But virtual service is the first step. So you can also use virtual services along with gateways. So gateways is another CRD that Istio provides. You can use them together to kind of control your ingress and egress traffic. So we'll also see a little bit more about that later on. So this is a sample from the application that we just generated. So I'll show the sample here. Store virtual service. So this is one of the virtual service that was generated by the application. As you can see here, we specify the host, and then we specify a HTTP routing rule with the routes, weightage that needs to be distributed, and some configuration about retries. Yeah, some configuration about retries. So the host specified here are the destination that the rules apply to. So the destination or the host here can be IP addresses, it can be DNS names, it can be Kubernetes service names, or wildcard prefixes. So you have a lot of flexibility here. So you can configure this. So in this example, the configuration is done for HTTP, but you can also do the same for TCP. You can do for TLS. So you can have mix and match. So you can do all that stuff. The HTTP, TLS, or TCP routing rules will contain destinations. Destinations and 0 or more match conditions. So in this example, there are no match conditions, but you can also have match conditions to kind of filter it further down, your traffic. You can filter it further down. So match conditions can be, against header fields. It can be against URIs. It can be against request methods, or it can be using a certain prefix that you want to check, or it can be against user identity. So you can do a lot with these match conditions. So the destination in the match conditions needs to be a Kubernetes service name or a virtual service or a service entry name. It cannot be IP addresses or hosts or DNS names. The rules are applied sequentially from top to bottom. So there are many other configurations available as well. I'm just showing the basics. You can also, if you look at the documentation for virtual service, you'll see that there are a lot more configurations that you can do here, a lot more things that you can configure. So this particular example is supposed to control traffic coming to the service from within the mesh, because it doesn't attach itself to a gateway. It just specifies these rules for a particular host. That means any traffic coming to that host from within the mesh will be handled by this rule. For ingress traffic, there is another virtual service. So let's take a look at that. So we have store gateway, which is a gateway definition. We'll talk about gateways a little further. So we have a gateway definition, and there is a virtual service definition here as well. And you can see here, unlike the previous virtual service, this also binds itself to a gateway. It binds itself to a gateway, and it has a bit more stuff going on here. It has match conditions as well for each destination. So this particular one, it is matching using URL prefix. So whenever it finds this particular prefix in the URLs, it will rewrite the URL and it will send that traffic to this particular host. So this is how we are routing traffic to different microservices. So if the URL contains invoice in its prefix, then we route that to the invoice microservice, similar to a notification, product, and finally the default, which is where's the default? Yeah, so this is the default. So anything that doesn't match with any of this will go to the store gateway. So this is the virtual service for the Ingress Gateway. So another thing to keep in mind is if there are multiple virtual services with similar rules, then they are kind of merged. And they might have some issues. If you have exactly similar looking rules, then it might not work well, or the merging logic doesn't have a predefined, doesn't have a strict priority or anything. So it might be merged one way or the other. So keep that in mind if you're having multiple virtual services for the same host. Of course, Istio best practice is to kind of break down virtual services into multiple, especially for different services. But then you have to keep in mind that you don't have conflicting rules or rules that could overwrite each other. So even this particular example that is generated actually becomes useless because we have another virtual service bound to the gateway. So any traffic coming via the ingress goes through that virtual service, and that kind of overrides this virtual service because it has similar HTTP routing rules. It is for the same destination. So it kind of overrides, and this kind of becomes useless. So I think I should probably change the template files in JHipster to make this better. I think I'll follow the Istio best practice and kind of break this big virtual service into multiple, so that each of these rules kind of moves here, because this rule kind of becomes useless because of this setup. So it makes sense to split this up and kind of move these into individual virtual services and bind those virtual services to the ingress as well, because at least in this setup there is no need for traffic within the mesh to have these kind of rules. So probably I'll make that change in JHipster in the future. For now, I think, anyway, for us and for the demo, this is good enough. Of course, this particular virtual service is overwritten by the other, but it works in this context, it works. So the next is destination rules. So destination rules, along with virtual services, is what makes it possible to do any sort of traffic policy management and the other cool features that Istio offers. So the destination rules are used to configure what happens to traffic once it arrives at a destination. So these are applied to these are applied after virtual service rules. So they get applied to only the final destination that is being filtered down by the virtual service. So the virtual service first runs the rules. It figures out which destination to send traffic to, and once that decision is made, then these rules are applied to that particular destination. That's why this is called destination rules. So destination rules are used to create service subsets that can be used in virtual services. So a subset is a way for you to define two versions of the same service. So you can have multiple versions of the same service, and then you can define rules in your virtual service to kind of route traffic to different versions. That is how you would do, say, A/B testing, canary rollouts, or region-based routing, or whatever. The destination rules are also used to define stuff like circuit breaking, your load balancer algorithm to use, connection pool settings, outlier detection, and stuff like that. It can also be used for TLS security and other network-related policies. The policies can be set for an entire destination or per subset. So the policies can, so in this example, the policy, this is again an example from what JHipster generated. So the policy here is set on the entire destination, but you can also move that entire policy to a particular subset. So you can have multiple subsets of the same application with each subset having a different rule. So there is a lot of flexibility here. And as with the virtual service, there is also a lot more configuration available. So it's not just this simple thing that you see. There is a lot more configuration that's available, and whatever you would encounter in a production setup, there are options to configure that, and there are ways to configure that. Thanks. And so the next important CRD that I'm only talking about CRDs that we would use mostly when you're working with Istio. There are also a lot more CRDs that you might use one time or few times in the lifetime of the application. Say for example, like there are CRDs for configuring authentication provider. There is CRD for modifying your service mesh configuration or stuff like that. But you won't be doing that all the time. You might be doing it once per application or whatever. So they are not the most important ones, but of course you can refer the Istio documentations to know all about all the CRDs that Istio provides. I'm only talking about the important ones. So Istio gateways are used to manage inbound and outbound traffic for the mesh. So a gateway can be an ingress gateway or an egress gateway. By default, when you use any of these Istio profile, there is going to be an ingress gateway deployed, like we saw here. Sorry, wrong screen. Where is the, yeah. So like we saw here, we have our ingress gateway deployed. In certain profiles, the egress gateway will not be deployed. So you would have to specify that if you want it, but ingress will always be there. So this particular example is for an ingress gateway. So gateway configurations are applied to standalone envoy proxies running on the edge. So these are not applied to sidecars running on your application pods. It's only applied to envoy proxies on the edge. So either ingress or egress. So unlike Kubernetes ingress gateways, you can use the Istio gateways with full power and flexibility of the traffic management system. That is what makes the Istio gateway better than the Kubernetes gateway, because Kubernetes gateway have limited features and limited flexibility. With Ingress, you get the entire feature set of traffic management, policy management, all that comes with virtual services and destinations. You can apply all that to a Istio gateway. So this makes it much better ingress gateway or egress gateway. So both ingress and egress traffic can be managed using gateways, as I mentioned. So a virtual service can bind to a gateway, as we saw here. So you can bind gateways to a virtual service. That way, whatever traffic comes from that gateway will go through this virtual service, and all these rules will be applied to that. So in this particular gateway, but it's quite again quite straightforward configuration. We define the servers, we define the ports and hosts to route that traffic to. So here we are just defining HTTP and HTTP2, which kind of Istio complains that this is not a valid configuration. I think probably the HTTP2 part can be removed. But I need to look into that further. But in a realistic setup, you would be defining your HTTP and HTTPS ports here, and will route traffic to whatever host you want from there. Then you will use the virtual services to configure the routing logic. Next important item in our Istio CRD is, as the name suggests, service entries. So you can use the CRD to add services to the internal service registry of Istio. So Istio maintains an internal service registry. I say it is internal because it is not exposed to the users. You don't have access to that service registry. It can only be accessed by it can only be used by the Istio daemon. Of course, you might be able to work around do some hacks to kind of have access to it, but by default, Istio daemon uses the service registry, and it is internal. But you have ability to modify that using the CRDs. So envoys proxies will treat the entries added to the service registry using this configuration as if it is part of the mesh itself. So service entries are very useful to kind of manage traffic for services outside the mesh. So you would use these to kind of add external services to the mesh. For internal things, you don't need this because Istio already kind of discovers them using Kubernetes service discovery or console service discovery based on whatever platform you're using, and then it kind of populates the service registry with that. So you don't have to do this for internal applications. You add these only for external services. So for example, if you're accessing an external API, say an external REST API, and you want to kind of control or apply traffic policies to those as well, then you use service entries to kind of add that into your service registry. For example, you can redirect and forward traffic to external APIs using that. You can define retries and timeout for external services, which otherwise you don't have access to because it's an external service. By default, Istio configures envoy proxies to pass through external destinations. So even if you don't define this, your external APIs would still work because by default it will pass through. But by adding this, you add the capability to kind of control those external services as well with destination rules and virtual services. So adding a service entry is only required if you want to manage the traffic to that particular external destination. Otherwise, you don't have to do this. So finally, we have a CRD, which you can use to kind of configure or fine-tune envoy proxy sidecars. So this is different from manual injection. So manual injection is where you add the sidecars to your deployment, and you use the sidecar CRD to kind of fine-tune the sidecars that are being added. So this includes configuring ports, protocols accepted by a particular proxy, or you can use this to kind of limit services that can be reached from a particular proxy, so making it more secure and more sandboxed. You can use the sidecar configuration. You can apply sidecar configuration per proxy or at a namespace level, so that the rules applies to every proxy in that namespace. This example configures all services in the book info namespace to only reach services running in the same namespace, which is the first line in the host array, and then the Istio control plane, the Istio system namespace, so that it can access Istio control plane and kind of provide telemetry. There are many more CRDs, as I mentioned, from Istio, but these are the most important ones and the ones that you would use the most. Okay. Oh, I think I was faster than I expected. It's supposed to be the break time here, but I think I'll do a code walkthrough first, and then we'll go for break. Is that okay? Awesome. So let's have a quick walkthrough. Okay. Okay, so do you want me to walk through the Java code or just the Kubernetes part? I don't want to. Hands, if you want me to walk through the Java, the application code as well, the JHipster part. Okay, lot of hands, so I'll do that. Thanks. Okay, so we have the store gateway. I think some of this might be a bit self-explanatory. For example, we have the dev container setup, a Docker setup for your dev containers. You can use it for testing and stuff like that. All the Gradle stuff is here. We have .jhipster folder where you have JSON files for all the entities that is generated. This is how you could update the entities if required, or keep track of what changed in your entities and stuff without having to kind of track them using Git or whatever separately. You have your Gradle configurations, Docker build setup, different profiles for dev and production, your war file setup if you want, Zipkin setup, Sonar setup if you want. So most things that you would need out of the books, it would be there. Of course, there is a lot that JHipster generates, so some might consider there is a lot more code there, or some might consider that some of the things you don't need. Of course, you can delete the stuff that you don't need, but the idea of JHipster is that when it generates, it kind of gives you everything with batteries included. So if you're new to this, if you're a newbie developer, or if you're trying to build an application, it kind of gives you everything you need, and then you discard whatever you don't need. Of course, if you don't like that that way, and if you want to exactly control what it is generated and what you need, then there is also the new JHipster Lite project. I think there is a talk later from Julian, I think Wednesday or something, about JHipster Lite. So maybe check that out as well. So you can use JHipster Lite to kind of fine-tune or create exactly what you want. It has a hexagonal architecture, so you could generate smaller applications with exact components that you need without all the additional bells and whistles that JHipster by default generates. So check that out if you're interested. We have some Webpack configurations here for the front-end build, and we have all the dot files. Most of them are front-end related, but you also have the prettier one. So we use Prettier for formatting all the code, including the Java code. There is a Prettier for Java plugin maintained by the JHipster team, which we use for the Java code formatting. Try it out; it's quite nice. Weird thing is it's still a Prettier, which is a JavaScript plugin, but it does pretty well, pretty good job at formatting Java code. We have a Gradle build file. We have the package JSON for the front end, and whatever else you normally would expect in a production grade Java project. And within the SRC, again, we have some Docker configuration files automatically. So if you want to use stuff like, say, for example, if you want to use the JHipster Control Center, you have a Docker file for that. To run monitoring, you have a Docker file with Prometheus and Grafana configured out of the box. You have a Docker file for the Postgres SQL, so that you can do your development without running a database separately. There is one for Sonar, running Sonar, and there is one for Zipkin. So as I mentioned, bells and whistles. And it even has Grafana dashboards predefined. If you use the monitoring setup here, it comes with all the useful dashboards already. So at the very least, you could use this for as learning tool to kind of do it in your application. Then of course we have the Java application itself, a very traditional Spring Boot Java application. We have the main class here, again a Spring Boot stuff. We have a web layer with REST endpoints for our APIs. So it uses the Spring resources, Spring MVC. You could also generate the exact same setup using reactive. So if you just add, say for example, so if you go here and add reactive true and rerun this, then you would get the exact same setup, but using Spring Web Flux instead of Spring MVC. So just with one line, you can convert your entire architecture to use reactive if you prefer that. So we have the resources, we have everything that is needed for that, like errors, like error definitions, like VM objects and stuff like that, filters. We have a service layer with service definition for all the endpoint, the REST services. We have mappers, we have DTOs. There is a security layer with, so this application uses JWT, so the security layer configures everything required for that. Of course, you could use JWT, you could use OAuth 2, you could use session-based authentication, then it generates everything accordingly based on that. Then we have the repository layer, which is made up of Spring Data repositories. Again, I think most of you probably are familiar with Spring Data repositories. They're quite nice, very, I mean, very not very verbose, quite straightforward. We have row mappers for some custom mapping. We have management stuff for security meters. I think this is again what do you call, like actuator related stuff. We have domain models where we have Hibernate JPA entities. We use Hibernate as ORM, so but JPA format, so that we use Hibernate underneath. We have the JPA entities here with all your fields and stuff generated, defined and everything. A configuration layer where everything is configured for the application, like your cache configuration. I think I defined Hazelcast as cache, so it does a Hazelcast configuration somewhere here. Where is it? What did I, or maybe I didn't do Hazelcast. Yeah, I did Hazelcast. Okay, it's interesting. There should be some Hazelcast stuff here. Okay, maybe someone removed something or some changes were done in the latest version. I need to check what that is. But again, not important. So we have configuration for database here, Jackson configuration. So yeah, basically like whatever you would expect, right? For a production grade application, you have all that configuration here. And some AOP stuff for logging. So that's the Java part. And then, of course, we have the resources folder with Liquibase configurations for your database. So there are change logs for all the tables. So when you run the application, it is also going to run Liquibase and create all the database tables for you. So it has change sets for each entity has a change set so that it creates its database tables. You could even add some dummy data using Faker. Of course, this is optional. You can skip this by passing a flag if you don't want this. But this is quite useful for testing purposes. There's an initial schema that has the user authority and those kind of tables set up. Then there is the data that is used for the user authority and stuff. And then there is fake data used by Faker if you are choosing to run with the Faker profile. Of course, the fake data stuff only gets added if you use this particular context, and this particular context is kind of enabled only use a particular profile. I'll go to that. Then there is the master XML file which kind of applies all these change logs. We have some we have a key store generated automatically for TLS if you choose to enable the TLS profile. There is a development profile, and in the dev profile you can actually kind of specify if you want to run Faker or not. So if you pass this, then it applies the fake data, so it is quite useful in development. But if you remove this from the Liquibase context, then it does not. So if you look at the production profile, then there is that there is no Faker profile here. So it uses the production profile. So again, we have dev and prod properties configuration here with appropriate database configurations. On dev, it uses H2 database, and on production, it uses whatever database you selected, that is Postgres. Of course, with the JDL, you can also specify to use a production database for development. By default, it uses H2, but if you specify particular database for development, then it will generate the configuration based on that, so that you can use that. There is also a TLS profile which you can use for security. And then there is a default application profile with the default configuration that is applicable to all the profiles or all the profiles. We also have some internationalization configurations. So when you generate an application with JHipster, you can choose to enable internationalization. And then you can say what languages are supported. So for example, for this particular example, I didn't choose any other language, so it generates with the English, but you can specify, I think JHipster supports around 35 languages. So you can choose from any of those languages and it will create internationalization files for all the languages, both for the backend and frontend. So for the backend, there is only very little in terms of internationalization because it just uses them for your mail templates and your activation emails and stuff like that. Whereas on the client side, if you look at, where is the client app? Here. So on the client side, it generates internationalization config for basically all your screens, all your entities, all your screens. So you can do internationalization quite well out of the box. So we have some mail templates and stuff here. Of course, we have a nice banner here, log back configurations. Then finally, we have the web application itself. So web application, in this case, I chose React as the front end. So it created a React client-side application. Of course, you could also choose Angular or Vue.js as the client, and then it will create those as the front end. So all the code is under the app folder. You have React configuration configurations, like setting up Axios interceptors or setting up Day.js for date handling or middleware to handle errors, stuff like that, a logger middleware, a notification middleware and stuff like that. Then you have entities, which forms the entity screens itself. So you basically have your whatever entities you define, it creates a CRUD UI for that. So you have a table list view. We'll see a demo after the break. It has a table list view. It has edit, create, edit, update screens, delete options, and all that basic CRUD. And this is all the entities for all the applications. Because we are running a microservice architecture, the store gateway kind of forms the UI layer as well. So for all the applications or all the microservices entities, it creates UI on the gateway client side. But of course, JHipster also supports micro frontends. And if you enable micro frontends, again, which you can enable in the JDL with one line, if you enable micro frontends, then the entities UIs will also be generated in the individual microservices. And we use Webpack module federation to kind of merge those into the UI. So when you create with micro frontends, the separate UIs will be pulled in using module federation and kind of served as a one UI from the store gateway. So you can also go that way if you want like true microservices. Then we also have some shared modules for account, administration stuff like metrics, log screens, and stuff like that. I'll show you a demo of that later as well. Shared configuration and stuff like that. There is also CSS and stuff, IATN. There is a Swagger UI setup also generated off the box if you want to use Swagger UI. Then we have tests, of course, Java tests for everything. I think pretty good code coverage here, enough to get a Sonar A rating, I think. So tests for all the, again, JUnit tests and integration tests for all your Java stuff, and also for the Webpack, for the web app itself, the tests are, where is it? For the web app, the tests are directly in the the application code folder, because that's how we do it in the JavaScript world. The best practice is to kind of keep everything together. If you're using JHipster Lite and follow the hexagonal architecture, then kind of similar approach is used for Java as well. Whereas here for JavaScript, the tests are along with the code, and for Java, the tests are separate as we normally do in Java. Then we have the Webpack setup for the front-end builds, and then you also have a RC file, which is the JHipster configuration itself. It kind of maintains all the JHipster configuration that was used to generate this application. So that's the code for the store gateway. So if you look at any of the microservice, it's going to be pretty similar, except for the glaring omission of the web app and the web app part. So that's the only difference. Everything else is pretty much the same. You have the Docker setup. You have Spring Boot application serving only the APIs and all the resource configuration and tests. So it's pretty straightforward. Now, let me see if I'm on track. Yes. So now for the Kubernetes parts. So for Kubernetes, for each of the application, so we have a deployment file. So as I already showed you for a previous thing, so it's quite straightforward deployment setup. We have replicas set here. We have pod affinities defined. We have a init container which waits for the database to be up before deploying this, so that your application doesn't fail. If you don't have this, and if you deploy this, then your application initially will fail because it cannot reach the database if the database is not up yet. So this is a nice setup which probably should be done, which probably everyone does in production, so that your application can start after the database. We have the application itself here with all the profiles and stuff. We have the JWT secret being injected, the database, data source URLs. Again, the databases are also deployed along with the applications into the same cluster. So we kind of just reference that within the cluster. You could also use external database if you like, and then you would just change the URL values here, and you might configure a virtual service, a service entry for that external URL, and a virtual service if you want to manage some traffic to it. We have the Spring Liquibase URL, which would be the same. Some resource and memory limits for the application, readiness and liveliness probe, so that we kind of know the application is up and running. So this is what we have for deployment. Then we also have a setup for the database for each application. So in Invoice, you have a setup for Postgres, whereas in Notification, you have a setup for MongoDB. So it will have everything that is required for the database. Like, for example, it has the secret, which is used as the Postgres password. It has the Postgres deployment itself here, and a service which is not exposed. It's a internal service for Postgres. And if you look at MongoDB, you have similarly all the required config map for that, even a bigger config map with all the startup scripts to make MongoDB work nicer. A huge startup script. Yeah, I actually never read this startup script. I was afraid. I never touched it. I did update it recently, but I didn't read it. I updated it, so I looked at the official Mongo Helm chart. I saw the script was updated. I was afraid to read it, so I just copied the script, put it here. I tested everything. Oh, okay, everything works. Nice. I'm not going to touch. I'm always afraid of these long, huge shell scripts. So I don't even understand half the stuff here. So I was like, okay, not worth the time. Apparently, you need to do all this for MongoDB to start up nicely, which is, yeah. Then we have the stateful set for MongoDB. So if you're using some database types, you can actually enable clustering for them in the configuration here. So in the deployment configuration, you can say cluster database true. And if it is a supported database like MongoDB or Cassandra or Couchbase, then this setup will enable clustering. Will enable a HA cluster for the database. So you can also enable that. So yeah, so that's it. And again, service also for the MongoDB stuff. Then we have a Kubernetes service for the application itself. And if you look at the store applications Kubernetes service, it has a port exposed so that you can access it from outside. Whereas for the other stuff, It also has port expose. Sorry, the difference is that this has okay, for a non-Istio setup, this will have a load balancer setup so that it can be accessed from outside. But for an Istio setup, everything will use node port so that you go through Istio for everything. And so we have the service, and of course we have the JWT secret for the application also created as a Kubernetes secret. And then we have the Istio part. So we have a virtual service, as I showed earlier. So it's a very simple virtual service for that particular host. Routes all the traffic, 100% of the traffic to version 1, has some retry setup as well. But this kind of becomes useless because we also have this one which overrides that. So I probably need to change the, as mentioned, I need to change the JHipster setup to kind of make it less useless. What else? Okay, then finally we have the destination rules. So the destination rules are again per application, and they are applied. So in the destination rules, we have per at the host level, we have only one subset defined here, and the rules are at the host level, or sorry, the destination level. And we have a traffic policy. We define random load balancer. You could also choose from other kind of load balancers that Istio supports, like affinity and stuff like that. We have a connection pool setting. Again, these are all used for circuit breaking. So we have a connection pool setting for circuit breaking. You can do that for TCP, HTTP, or whatever protocol you want. You can define max connections and stuff like that. You can do outlier detection. So again, fault tolerant circuit breaking concepts. So you can, you can kind of detect if there are similar errors happening for a certain number of times, and you can route to a different, service if that happens and stuff like that. Very useful if you're doing A/B testing or canary rollouts and stuff like that. You can kind of monitor what's happening for your application, and you can make changes accordingly. And the nice thing about Istio is you can apply these destination rules or virtual service on a running cluster on a need basis, and you can control how your traffic flows in real time. On the store applications configuration, there is an extra gateway configuration. So we configure Ingress Gateway here, and we kind of route all traffic coming to this gateway to our store application. And then we bind that gateway to a virtual service, and then we have rules, HTTP rules, because we are only handling HTTP here. We have HTTP rules to kind of detect prefixes in the URLs being accessed and route them to appropriate microservices. And anything that is not handled, again, goes to the store gateway. We'll, I think after the break, we'll play around with these files, and we'll try to do, say, some A/B testing setup or canary rollouts and some fault injection and stuff. We'll try all that stuff here. Virtual service, yes. And finally, we have the Istio related stuff, like for monitoring and observability. We have gateways and virtual services defined for Grafana, Kiali, and Zipkin. So again, a very simple gateway that routes all traffic coming to, on the Istio namespace, routes traffic coming to Grafana in this particular case, and then we attach that to a virtual service, which says what matching rules are being used. So we have a similar setup for Kiali, and we have a similar setup for Zipkin. So since we also specify, where is the host? Yeah. So we specify hosts. This entire setup of rules will only get applied to that particular host. It doesn't get applied to everything. So this is the configuration that is created out of the box by JHipster. So I think. So after the break, we can think we are. Yeah, I think we can have a 30-minute break now, and after the break, we'll deploy these, and then we'll play around with the configurations to kind of try out what you can do with Istio. Like we'll do A/B testing setups, we'll do some canary rollouts, we'll try some fault injections, we'll see what security options you can do, we'll see how we can extend Istio further using Envoy modules, and we'll see how you can do OIDC or OAuth authentication with Istio and stuff like that. So let's do all that after the break. Thanks. Welcome back. Okay, good to see similar crowd. I thought half the people will leave, and then I'll have a smaller crowd. But hey, nice. So I'm going to take a photo as a proof that people stayed. People stayed after the 1.5 hour mark, and people didn't leave. So. Nice. Thank you for everyone who came back. And yes. Okay, so we'll start with the deployment now. Let's go back to all namespace so that we can see. Okay, so we don't have a JHipster namespace now. Let's go back. So go into the Kubernetes folder. Okay, I'm going to use the script, and as I mentioned, we have a handy script here. Just prints out some useful information. Basically it applies the namespace and the namespace definition, very simple. Then configures the Istio injection and applies individual application manifest, and finally applies the Istio gateway configurations for Kiali and stuff like that. There is also configurations for customize and scaffold. If you want to use those with Kubernetes, then there is some basic setup also available for both customize and scaffold if you want to use them. So you can utilize them if required. I'm just going to use the normal Kubernetes stuff. Okay, so this should start creating the containers, and if everything goes well. Yeah, there are some warnings from GCP about deprecation of the authentication plugin and stuff like that. Not very important for us. And we can see the containers being created here. We have the invoice Postgres already running, the application, invoice, notification, product and store. The databases are already up. MongoDB is not yet there. So it's going to take, I think, a minute or two for everything to be up. Okay. Up yet? Nope. Okay. I'll just prepare. Oops, I closed it. Is it up yet? Nope. So we can access only when the store is up. Let's see what's happening at the store. It's not running yet. No logs yet. It's starting up. Okay, I think it's up. Yeah, all our applications are up. So it prints out useful URLs. It's nice. So we have our application. I'm going to sign in using the default credentials, which is admin. The safest combination ever. No, I don't want to say this. Yes, I know. Yes, no, never. Yeah, that never doesn't work because of the IP. It always asks anyway. So we have the application, we have our entities. So the customer entity is on the store itself. So let's try just creating something. Um, required. All the fields are required. And assign it to a user. Okay, so this is the CRUD screens I spoke about. So you basically have a list view. You can view them, you can edit them, so and so on. And we have the other stuff. So we have entities from the product microservice. So let's see if this works as well. If everything is set up correctly, this should create. This is calling services from the microservice. Yes, it is working. So we have similarly product order, product, and we have from the invoice service. As you can see here, look at the ID here because it's running on Postgres, so it's just using an incremental ID. Whereas if I go to notification, which is on MongoDB, and I create something, so you can see it is using the MongoDB's UID as primary key or ID part. We also have the administration screens. We have user management with 2 default users. We have metrics. So this is from Spring Boot. We have all the actuator metrics and stuff. We can expand and see stack trace and etc. for the application. We have HTTP request metrics. We have endpoint request metrics. We have catch statistics. We also have a health screen where you can see status of individual components. These are not these are showing unknown because we are running on Istio. So a little bit more tweaking needs to be done on the actuator side for these discovery, all this discovery stuff to work. You can see the disk space and stuff here, for example. We also have a configuration page where you can see all the application configuration. So this shows all the merged configuration used by the application or the current configuration that is being used by application. So it's based on whatever profiles you applied, whatever configurations you passed as environment variables. So the final configuration that the application is using. Of course, sensitive data is kind of obfuscated and everything. Again, this is from Spring Boot. We just provide a UI and use those. And we have logback configuration here where you can kind of change the logging levels at runtime. Very useful, especially in development, even in production sometimes. You always debug in production for all those brave people who debug in production. How many of you have debugged in production? Yes, I have debugged in production. I'm proud of that. Not much, but it was nice. It was not a very critical application. And we have the account stuff, user settings where you can change your name and stuff, registration screen, your password reset screen, and sign out. So that's basically the application. Not that interesting for this particular aspect because we are talking about Istio. So let's go back and. Let's look at some of the telemetry stuff that we have. I'll get comfortable to talk about telemetry. Okay, we go back here. So we configured Grafana, Zipkin, and Kiali. Of course, also Prometheus underneath because Prometheus provides the data for Grafana. So let's look at what we have in Grafana. So we have the default setup, and there is an Istio folder with predefined dashboards configured by Istio. Of course, you can provide your own dashboard configurations so that you have nice dashboards for your application telemetry and stuff. But these are the out-of-the-box ones provided by Istio. So we have a control plane dashboard where you can see all statistics for the control plane. We have information about pilot activity, information about what Envoy does, and webhook information. We also have mesh dashboard, which shows metrics for your the overall mesh health and everything. We also have a performance dashboard where you can kind of see how much CPU memory and etc. are being used by your mesh. We also have a service dashboard. So this is quite interesting for the application itself, because the service dashboard kind of shows all the client workloads, and you can go here and filter, database, data source is Prometheus, and service, we can go here and filter by service. So let's filter by the product database. So you can see what's happening at the database, for example, or let's see at the product service itself. I can see how a product service is performing. So this is all out of the box. You can filter around, you can get different dimensions for that and everything. So that's the service dashboard, which is quite nice. And if you run some sort of load testing against the application itself or the API, then you will see this being populated with much more data. We didn't do much with the application itself, so there is not much data to visualize here. And we also have a Wasm extension dashboard. I'll talk about why we have a Wasm extension dashboard later on, because it has to do with extending the Envoy proxies itself. But we also have a dashboard for that when we go into extensions and stuff like that. And we also have a workload dashboard, which again you can filter by namespaces and specific workloads and see how like the request and response rates and stuff like that, and performance of that particular workloads. So these are all what you get out of the box. And of course, like any other Prometheus Grafana configuration, you can provide your own dashboard configurations and settings, and you can create your own dashboards and charts and settings to visualize whatever you need. Istio basically provides all the traffic to Prometheus. It collects all the traffic in your mesh, so you have a lot of data sources to work with. So that's the Istio part. We can also access Prometheus. So before we go to Prometheus, let's. So for Grafana, I think we already went through this. So to make it a bit more, to set the context a bit more. So this is how we configured the gateway and virtual service for Grafana. So we had a simple gateway that that sends all the traffic to this particular host, which is our Grafana host running on the Istio system namespace, and we have a virtual service bound to that host and gateway, which just routes all traffic to this Grafana service. So it's quite straightforward. And we don't have virtual service gateway combination defined for Prometheus out of the box. So we can access it in two ways. One, we can either create the combination and access it through Istio Ingress Gateway, or we can also just port forward and do it. Let me see what the Prometheus one is. Did I hear a baby crying or something like that? Was it just me, or did you all hear that? Just me? Okay, and it is 1990. So we have the Prometheus collecting all our data. So let's, what can we look at? Probably it doesn't have any logs. Okay, it has one entry. Uh-huh. As you can see, it has too much data being sent. So basically, you get everything in Prometheus. So you can build a lot of dashboards with the data that is being collected. So there is a lot of metrics to select from. So much so that I'm trying to find something with a lot of. Nope. Istio request was there, right? Yes, that would be a good one. Yeah. Oops. Oops, no. I think probably this will have something. No, really? Yeah, okay. So yeah, basically we have Prometheus metrics. I don't know what I was trying to show here. So we have Prometheus metrics with so many dimensions that it is sometimes very hard to pick what you want. There's so much here, which means basically you can create whatever your heart desires in Grafana, whatever kind of dashboards you have in Grafana. And of course, you can also customize the Prometheus configuration further to do more. And I think someone was asking if how would you restrict this telemetry if you don't want to collect all this telemetry, because this is a demo profile. It kind of sets up everything. It kind of gives you everything. But in other profiles, you can choose to kind of provide your own configuration. So you control what is gathered. Also, you can kind of create sidecar configurations to restrict certain applications from sending telemetry if that is what you want, or so there is a lot of options for you to configure this, and there is a lot of options for you to play around with this. But the nicest thing is that Istio kind of gives this out of the box, and it kind of works flawlessly out of the box. So next we have, I'm going to shut this down. We have Zipkin. So what is a distributed system without distributed tracing, right? Of course, we made everything so complex that we now need new systems to kind of work with the complex systems we already created, more complex system to work with the complex system we created. Anyway, with Zipkin, or if you prefer Jaeger, Istio also provides Jaeger chart out of the box. You can install Jaeger and use that instead of Zipkin. They are pretty much very similar. You don't even have to change the configurations. You just need to change the name, and it kind of works. They're pretty similar standards. But let's say, so if you run this, you get everything that that happened in the some last 15 minutes or whatever. So you can change that to, let's say, last 1 hour. I'll get more. So you can see what requests are going on in your mesh, and you can kind of dive into them, and you can see more details. Let's send some requests so that we have something for the invoice system or something like that, so it makes a bit more sense. Yeah. Okay, product category, I'm going to send few requests for these. So we have the last one, which is, I think, this one. Yes. Yeah. So this is one for the store itself. And where is the one for invoice? This is from the Ingress Gateway, goes to the store. We also need one for the invoice. No, product, I think. No, it's again to the store. Where is the one for product? It's here. Yeah. Yeah, so basically it kind of gives you distributed tracing for whatever mesh traffic that is going on. You can, if you have more services talking among themselves, then you get more layers. Here we don't have a lot of inter-service communication. We only have from ingress to store or from ingress to a service. So this is the only communications that we have in this microservice setup. So the trace levels is going to be ingress and the application at max. So you're not going to have multiple level. But if you had communication between individual services, say for example you have a route in your microservice where you get something from the ingress, it goes to the store, then store calls product internally for something, and product calls notification for something, then you would have that stacked here, like from ingress to store to product to invoice. So you see exactly how a request is being passed around, and you can see exactly what happened with the request. If something failed, you will see exactly where it failed. So this is very helpful for distributed applications. You can trace what is happening, you can debug them in better ways. So it's quite useful with Zipkin or Yager. Yager also provides similar setup. I think Yager has a nicer UI, but Zipkin is more open source friendly. So, and finally we have Kiali. So Kiali is a distributed application monitoring solution, which is specifically for Istio. This is specifically for Istio. With Kiali, you can see, say for example, for each namespace, you can see what Istio configurations you have. For example, here, it shows that we have 7 applications and there is some warning. So if I go in, I can see everything on the Istio system namespace, and it's complaining about the port configuration. As you can see, it even kind of links and tells you if there are, I don't know, possible issues. So here specifically, this one, this particular error code, this is Kiali specific error codes, which you can look up, which says that, okay, this particular port host has 2 server configurations for the same port, because we have a HTTP and HTTP2 configuration. So similarly, you can also see that for other namespaces. So if I do it for the JHipster namespace, then you can also see all the Istio configurations for that particular workload. So with Kiali, so if you're running Istio, I think it makes sense to have a Kiali as well. So to set up Kiali as well, because you can kind of monitor what Istio does. You can see everything about the Istio setups. You can go into Istio configuration without having to do use kubectl or whatever. You see some traffic information here. And this is also quite nice that they have a graph which shows all the network nodes that you have and all the communication that is being happening. So for our application again, there isn't any inter-network communication, so you only see these kind of traffic. But for is it? So if I increase this to last 30 minutes, then you see even more. Oops. Yeah, so it kind of basically, so over time, especially if you're running your setup for some time, it is nice to know what's happening in your entire network, right? So this graph kind of provides you that bird's eye view of what's happening, what services are being called, and if there is a particular path that always throws error, then it's going to be highlighted differently. I mean, if there are errors, then those paths are going to be highlighted. Then you know there is something wrong with that particular path. You can look into that. You can fix that. So for people running, Istio service mesh on production, these are the advantages that it offers, these kind of things. Not only the advanced routing setup or advanced traffic management, but also advanced telemetry and advanced observability tools, so that you can kind of you kind of exactly know what's happening in your mesh. It's easy for you to find issues. So for example, if there is a path that is intermittently throwing error, you are going to see it highlighted, and you can already start investigating what's happening there before it becomes a outage or something. So it's very helpful for that. It also has your applications listed. You can go in and see per application what's happening. It even shows you the average response time and everything. So you can set up I mean, you can monitor this to know about issues before it even happens, or possible issues before it happens. As you can see, it shows all the sidecars. We don't have any sidecars for our Postgres databases, so it says that they have missing sidecars, which is expected. We have workloads here as well. We have services. So we have stats and traffic for services. You can see the traffic information. You can see the inbound metrics for each of these. So all these are quite useful if you have Istio. So I highly recommend Kiali if you are using Istio, because it's made for Istio, so it works great. Finally, we also have all the Istio configuration per namespace here. So you can go in and see the configurations here. You can even edit the configurations directly from this. So you can edit and save this configuration, though probably better to do it on your source and have it in your Git and everything rather than doing it here, because this will not, then you'd have to sync. But if you want to try something out, if you want to quickly fix something, then yes, you don't even have to do a deployment. You can do the change here and you can apply that. So that's a nice thing. So yeah, so that's about Kiali. So let's see what else we have. And yeah, so if you wanted to install Jaeger instead of Zipkin, then it's available in the samples, add-ons, Jaeger. So it's available in this path if you want to use that instead of thing. Let me quickly try if that works without any setup. It ideally should. Okay, I need the port. Where is Jaeger running? Jaeger. So it's 14268. Doesn't look right. Huh, interesting. Oops, no, that's not the right port. Ah, 9411. It's 9411, right? Yes. Might or might not work, but wait, that's the right port, right? What am I missing?
Looks like this is the endpoint that collects traces.
Sorry?
This is what collects the traces.
Oh yeah, probably I'm looking at the wrong one, huh? Oh yeah, it's a Jaeger collector, yes, thank you. Okay, there is no service for that. Yeah. Yeah. Yeah, I need to create a service for that at least in order to access it. Anyway, I'm not going to do that right now. And I need to finish I'll finish the thing, and if there is time left, then I'll create a service and go on. Anyway, this is not the important part. The important part is playing around with Istio. So I think this needs a service at least to port forward. Okay, so what's next? Okay, so playing with Istio. So let's see some examples of routing requests and traffic splits. So we can try kind of do some canary rollout or A/B testing kind of things. For canary rollouts, we can use weights to shift traffic. So as we saw earlier, we have destination rules and virtual service. So with this combination of those, we can kind of do traffic shifts. On a destination rule, look at the things in bold. So we can add multiple versions for the same application. And on the virtual service, we can add destinations for each of those subsets. So in the destination rule, these are called subsets. So you can have can have any number of subsets for an application, and then on the destination rule, on the virtual service, we will have destinations as those subsets, and we can weight the traffic. So we can have any number of splits, 100% or 80-20, 50-50 or whatever. And it will route traffic accordingly. The load balancer will route the traffic accordingly. So that's how you do traffic shift, and that's how you can do canary rollout. So canary rollouts is when you have a new version of your application and you don't want to deploy that for everyone. You want to gradually increase. So you say, for example, you have version 2 of your application. You want kind of say send 20% of the traffic to the new version, while use the older version to handle the remaining traffic. So you will deploy the new version, set the weight here as 80-20, and 20% of traffic will go to the new version. You will monitor how it performs. If you want to do A/B testing, you can also do that with that. And when you're satisfied, you can slowly increase. You can make 50-50, and then you can switch it to 80 to the new one and 20 to the old one, and then finally you can switch 100% to the new version. So that's how you shift weights and do canary rollouts or canary deployments. Similarly, you can also do A/B testing, but with more configuration. So let's try this. So for that, first we need a version 2 of our application. So let's do some simple changes so that we know that we have the right thing. So let me go to web app, content, CSS, app, app.css. So I'm going to change this to, what would be very obvious? Okay, bright red. Yes, bright red. And just so that we are sure, I'm also going to change it here. Background color, something like this. Okay, so we have some change in our application. I'm going to build this store. Okay, so let's build this store v2. Let's call it store v2. So while this builds, let's go ahead and create a new deployment for this. So we have store deployment. I'm going to copy this and edit it to store deployment v2. Okay. We need to make some more changes here. So let's name it v2 and version v2. Again, here as well. So version is v2. Okay, I changed all the versions to v2. The name has been updated so that it doesn't overwrite our existing v1 application. Init containers doesn't have to change. And here, let's say v2. Wait, did I add a? Yeah, so v2. Okay, so we have our deployment. So let's deploy this first. Okay, let's Kubernetes kubectl apply -f store kts store deployment v2. Okay, so the deployment is being added. It should appear here. So we have, so this is our existing v1 application, and we have our v2 application being created. So let it start up and run. Okay, let's wait for a second. And let's go ahead and change our, so we'll try this now. We'll create, for the store application, we'll create a subset, and we'll add some destination rules and stuff. So for the store, okay, and as I mentioned, since this kind of gets overwritten, I'm going to do it here, because this is what will have the final thing. So I'm going to, okay, I first need to create subsets on the destination rule. So on the destination rule, I'm going to create v2, and which version is v2, and on the gateway we can change this. Oh, wow. Okay, we don't need this anymore because we have new rules. Okay, so we are sending 50% to v1 and 50% to v2. So let's see if our application is up. Yes, our application is up. Let's deploy the service. I'm gonna just do this so that everything gets applied. I mean, it will not overwrite. It will only apply the ones that changed anyway. Okay, so hopefully it's okay, we have loading. I'm going to refresh it a few times to see if probably coming from cache. Let me disable cache. Yes, cache is disabled. Yeah, so you can see each time it's going to a different one. Something wrong with the loading of CSS here, but yeah, you can see it's kind of alternating between v1 and v2. So we are shifting traffic, and we can also go here and say 0. So let's say we did our canary rollout of slowly increasing, and finally we want 100% here. So we can also just say this, or we can also just remove this also, but just to show that it works. We do this, and then we apply it again. Might take few seconds for it to propagate to all the containers and stuff. So now it always goes to that one. So this is how you would do traffic shift. But this is a simple version, right? We can also do more. So we can also do advanced routing, and this way you can do, say, let's say A/B testing. So let's say I want to A/B test where I want to treat requests coming from Chrome. I want to send all the requests coming from Chrome to version 1 of my service, and I want to send everything else to version 2. So I want to split traffic based on browser. So I can do that. Let's say, okay, let me just, so we go here. on the store gateway, and let's remove this. Oh man, I don't know why it is adding space, new lines everywhere. Yeah, I know why. It's because I copied it from the slide. Anyway, so so we don't need all this. We just need the match, the route, and destination. So all this can stay, and this needs to go. I need to. Is it matching? Yes. Okay. So here we have a match and a route and match. So the match looks for all prefixes, and if the header has Chrome in it, then it routes to v2. So let's say our host is store and subset v2, and everything else it goes to v1. So or let's say do vice versa. Let's do this to v1 and everything else to v2. Okay, don't need this. Yeah, looks okay, looks okay. Okay, looks good. Let me apply that, and let's go here and refresh. So Chrome, from Chrome, we are getting v1. Let me run Firefox. And if I access the same from Firefox, I should be getting the v2. So you can do all these kind of. So this is just like a sample of what you can do. So with the match, you can do a lot more. So you can match against headers, right? That means you can match for identity. You can match for, say, if you have OAuth applications, you can look for the claims in your headers, and you can send different roles to different versions of your application, or you can route traffic based on the user or a pattern of user, or you can route traffic based on authenticated users and non-authenticated. You can send authenticated users to one version of the application, and the non-authenticated users to other version. It doesn't even have to be this different versions of same application. You can send to entirely different applications as well. Doesn't matter. I mean, Istio doesn't care if the subset is the same application or not. It just cares about which subset you are providing. So you can send to different applications, different services, or different versions of the same whatever. So you can do all this with the routing policies, right? And fault injection. Okay, so next is fault injection and circuit breaking. Again, so for fault injection, we can inject delays into your application, which you can do in the virtual service level. So that can be per route or per route definition. So for example, here for the HTTP route of store v1, we are adding a fault delay fault of 10 seconds to 100% of the request. You can also say for 50% of the request, add a delay of 10 seconds, or for 5% add a delay of. So you can kind of simulate loading, real world load scenarios for your application during testing phases, for example, to see how it performs, or see how faults are handled, and see how timeouts are handled. So you can do that. You can also inject errors. So let's say in this example, for store v1, we are injecting 503 errors for 100% of the request. So all of your requests will return 503. So this way you can inject, you can introduce a error on purpose and see how your mesh performs. So for example, if you have other circuit breaking logics or other retry logics going on, then you can inject these faults, and you can kind of test what happens. So let's quickly try it out. So let's quickly try, let's try fault. Okay, so about I'm injecting a 503 for everything that goes to V2. It's on the right one, right? Man, YAML. That would have been, I would have spent like 10 minutes figuring out why it doesn't work if I didn't see that space. I hope Bruno is not here. He would have loved to see all this in YAML. Okay, let's apply this. I did it for V2, right? Yes, V2, so not the Chrome one. Okay, then I need to go to V2 is here. Oops, not working. Not working. Why is it not working? It's maybe let me try this. Is it the indentation? It should be under destination. I mean, it should be. Oh, yeah. Thank you. YAML. YAML. Yeah. It's always fun, right, with YAML? And also with Python, I think. Similarly fun. Okay. No. Wait. Probably I again applied it to the wrong one. It should be at the same level as root on a match. So it's not a separate item. So it should be for a match at the same level as fault, right? Sorry, same level as root. So isn't that what here it is? So it's for match, same level as fault. Okay, let me try to comment this out. Yeah, it normally should work fine, but this is definitely, I'm doing something weird. It's only on JHipster we have auto injection enabled and everything. Let me see if all the virtual services are. What? Ah. I have really nice audience who are paying attention. I like that. Okay, so gateway. Where did the fault go? It's not applied for some reason.
Why not use Kiali instead?
Yeah, can use that as well. Yes, you're right. I think that was not propagated. Sorry? Oh yeah, let me. No, it's the store gateway, the right file, virtual service. It is the right file. But for some reason, it's not propagated. Let me try again. Or Kubernetes store. Oh yeah, there's a validation error. Okay, error validating. Unknown field percent. Really? How is that an unknown field? That is a right field. Wow, I was so happy that everything was going so well without any issues. Damn it. Every time. It's not wait, it's pause. Okay, let's be sure. could be wait. Yeah, you could be right. It's probably me who did the let me, where do I have it open somewhere here? Virtual service fault. You're probably right. And thank you for that, but I'm just going to make sure. I'm pretty sure I copied it from working. I tried it and it worked, and then I copied it to my slide. Unless I don't know, I messed something up. Let me quickly check the documentation for what it is. Man, there's so much stuff on here. So this is under HTTP match request, under query para, no, under root. Under root, right? No, fault. HTTP fault injection. So there is delay and abort, and I'm using the abort one. And for abort, it is percentage. Really? Damn it. It is percentage. Wait, then why do I have percent here? No, so they have both okay, this is weird. So for abort, there is only percentage, but for delay, there is percent. So it's inconsistent. So I did for delay, I tested the delay, and the naive me, I thought it's the same, right? So I just changed it to abort in this one. so delay, so yeah, that's good to know. Good to know. So yeah, seems like delay has both percentage and percent, but if you're doing delay, percentage is not int value, it's an object. So with delay, it has to be like this. This is very weird. This is quite inconsistent. I don't know why this is like this. So if you're doing delay, it has to be like this, and if it is abort, it is percentage. But for delay, you can also do percent with the value directly. Very consistent. So yes. Thanks for who noticed that. Wait, it was percentage, right? Sorry? Yeah, it is open source. So probably, yeah, you should fix that. It's not intuitive, right? You would expect it to be similar. Okay, so this should work. No, still. What did I do? No, not for this one. That's the problem. That is only for okay, for this one. Okay, let's see. Let's do what works. This side for sure worked. So percent and what was the other one? It was fixed delay, 10 seconds. Let's make sure that works. Fixed delay, 10 seconds. I should have just gone with the one I tried and I knew worked instead of trying. Suddenly wanted to try the abort instead of delay because I already tried the delay. So, okay, at least it didn't fail. So I think this would work now. Yeah, so this is working. So there is a delay now. So it's going to wait for 10 seconds before serving. So either it will time out if there is something else that if we had a timeout, I think we had some timeout, but probably not 10 seconds. So it waited for 10 seconds. So that is definitely working. So either the documentation for abort is wrong because the documentation here says, the documentation here for abort says you can use percentage with value and HTTP status. So this should have worked. This, so 0.1. So what kind of value is this? It's not an integer. I mean, it's an integer, but like, yeah, it's 10% probably. I'm just going to say 1. So 100%. Abort. Let's see if it works. Ah, yes. Thank you. But it's nice to have errors, huh? So everyone is paying attention now. I should do this on purpose more. Okay. Let's. Sorry? 100? Okay, let's try that. Ah, okay. But they had point values. Ah, let's try. Yes, you're right. Yes! Finally! Abort! I was never happy to get an error like this. Yeah, that was fun. But so that was fault injection, and I forgot what flow I was in. Yes, slides. Yeah, so we can also do circuit breaking. So for circuit breaking, I think we already saw the generated one. So you can set connection pool stuff like for different protocols. You can set max connections, timeouts, max requests, whatever networking supports, right? You can set all that. There are a lot more properties that Istio supports. If you look at the documentation for the destination rules, traffic policy, you'll see that there is a lot more you can set here. So you can kind of mix and match these values to get exactly what kind of circuit breaking configuration you want for your different applications. You can set up outlier detection. You can set up retries. So connection pool stuff and outlier detection goes to destination rule because they are applied to the destination, the final destination, whereas retries go to the virtual service because retries are applied at the source. So you can set up retries in case of failures and stuff like that. So these are all the circuit breaking capabilities that you can do with Istio. I have 13 minutes left. Yes, go a bit faster. So finally, security components. So Istio also offers a lot when it comes to security. So there are a lot of components. These are all the components that is available. So you have a certificate authority for certificate management managed by Galley. You have configuration API server that distributes the configuration to the proxies. It distributes authentication policies to the proxies, authorization policies, naming information. You can distribute all that. You have sidecar and perimeter proxies. They work as policy enforcement points. So this is what secures communication between clients and servers. You can set up that. And you also have a set of envoy proxy extensions to manage telemetry and auditing. We'll look into a little bit more of the extensions later. But this is all the security components that you have. And you also, and this is the security architecture of Istio. So we have mutual TLS on the mesh traffic in the data plane, which you can see in the green line. So all the traffic within the data plane is, by default, is mutual TLS. MTLS, and it can work for HTTP, gRPC, TCP, or whatever. You can configure further policies for that in your destination rules. You also have certificates on the proxies and controllers, like ingress and egress controllers, which you can manage with Istio. You have authorization on ingress and egress that you can manage. You can hook these authorization to external providers like like Okta. I work for Okta. Like Okta or Auth0, like Keycloak or whatever. You can plug all these authentication providers to Istio for authentication, and you also have local authorization there on egress and ingress. You can have that. So this is the security architecture of Istio. So there is a lot of things you can do, and Istio supports JWT out of the box. It passes JWT information around. You can even configure JWT directly in your Istio configuration. So there's a lot of flexibility and options here. In the sample application that I used here, the authentication and authorization is managed by the application itself. It passes around JWT header, so you don't have to do anything in Istio. That is also an option. But you can also choose to do it at the Istio level. So you can do all the authentication, authorization at Istio level, and you have your applications. Don't worry about any of that. That is especially useful if you are using something like OIDC, where you actually manage all your auth needs in the OIDC provider, like you manage all your groups, authentication claims, and whatever in your OIDC provider, and you hook that up to Istio, and your applications don't have to care about that at all. So Istio and the provider will work together to take care of all that. Istio will only allow requests which are authenticated, and yeah, you can forget about authentication within your application. So there is a lot of options for security. And for authentication specifically, there are two types that Istio supports out of the box. So you have pair authentication. So this is used for service to service communication. So this is between services in the mesh itself. So this authentication is used to verify the client making the connection. So Istio offers mutual TLS as a full stack solution for transport and transport authentication. It can be enabled without requiring service code changes. So your applications don't have to do anything. This is all at Istio level. So it provides each service with strong identity representing its roles, which enables interoperability across clusters and clouds. It provides that secure service-to-service communication. It provides a key management system to automate key and certificate generation, distribution, and rotation for these services. So it's a one-stop shop for all your security needs within your mesh. And the second way is request authentication. So this is used for end-user authentication to verify credentials attached to the request. So it's often done at the ingress and egress levels. So Istio enables request-level authentication with JWT validation. It has a streamlined developer experience using custom authentication providers as well. So you can use any OpenID Connect providers like Keycloak, Okta, Auth0, Firebase, Google Auth, or whatever. Any OpenID Connect, any provider that is following the OpenID Connect spec, you can use that with Istio. So that is one option. And finally, if you are doing OAuth to an OIDC, so I do have to put a disclaimer here. Doing OAuth 2 in Istio is a bit more involved than doing it on a traditional microservice stack. For example, even with the JHipster setup, right, that I used. If you're using this JHipster application and when you generated, if you used OAuth 2 as authentication instead of JWT, the entire generated application is going to work flawlessly with OAuth 2 because the store gateway, in the setup, the store gateway will have integration with the, say for example, I'm using Okta or Auth 0, right? It will have the integration to talk to Auth 0, validate requests or authenticate requests, and then it will use that information, and it will use Spring Cloud Gateway to pass that JWT information to all the requests that is going to the services. So everything works within the application beautifully. But it is hard to get the same working in Istio, because Istio, when it comes to OAuth 2 and these kind of things, it's a bit more involved. Application level OAuth 2 on Istio needs a lot of fiddling, a lot of tweaking the virtual services, tweaking destination rules, URL rewrites, and this and that. Looking at headers, allowing headers, and all those stuff. It's quite involved. Another option, or I would say, it is also involved, but maybe a less complex option to debug and work, might be using an external plugin. And one of the most popular plugin used for this in Istio is called OAuth 2 Proxy. So the link that I have put here, it's from someone else, but I found that as a most recent comprehensive explanation of how OAuth 2 Proxy works with Istio, because normally if you go and search for OAuth 2 with Istio, you will get like 100 posts, and all of them will do different things using different versions of Istio, which might not work. And most of them, if you try on the latest version of Istio, it's not going to work. So this is the one I found that works the most, or does the pretty good job of explaining everything, because it's quite it's a bit complex to set up. You could also use something like Open Policy Agent to do this as well. So that is option. You could use, you could use. There are many other plugins also that can work, but this is a well documented, or at least mostly documented solution. So it works. It works this way. So you set up OAuth 2 Proxy as a container on your mesh, and you provide a configuration. So Istio has CRDs, or custom resource definitions to modify your envoy proxy itself. Right? You can configure the envoy proxy, and you can register envoy proxy plugin. So you kind of register OAuth 2 Proxy as an envoy authentication layer plugin, and with that, and then you set up the OAuth 2 Proxy to talk to your IDP, or like Auth 0 or Okta. You set up that to talk to them, and then whenever Istio hits an authentication request, it diverts that to the OAuth 2 Proxy. OAuth 2 Proxy will talk to your IDP. In this example, it is Keycloak. It will talk to that. It will validate your request, and it will pass that information back. And then Istio knows that, okay, this is a validated information because this plugin told me it is validated, so it doesn't care about that, and it allows that request. So that is how it will work with the OAuth 2 Proxy setup. So for OAuth 2 on Istio, OAuth 2 Proxy is a good solution. I would say it is the less involved solution than trying to make it work within your applications, because then you end up fiddling a lot. Of course, you could build custom solutions, you could use other providers, but just know that there is a lot of fiddling involved. It's not cakewalk like how we did traffic policies and stuff. Those are quite easy, but when it comes to authentication authorization, it's a bit more involved. So finally, I have 4 minutes left, and right on time, yes. So finally, you can also extend envoy proxy using WebAssembly modules. So WebAssembly, or WASM, is a standard that was created for the browser, where you can run a binary format in the browser, return in whatever supported language, and the binary runs in a sandbox, secure sandbox. It's cross-platform. It's very lightweight. It can have instant starts. It's extremely fast. So it's a great format. I have an entire talk about how WebAssembly can replace containers, and we can go containerless finally. I'm trying to make containerless a word, like serverless. So so you can use WebAssembly to kind of extend envoy proxy. There is also a proxy WASM API that is provided by the envoy proxy Istio teams. So they have SDKs for C++. They have SDK for Rust, assembly script so far, so 3 languages. So you can write your extensions in any of these languages, bundle it as a WASM binary, and you can use that with Envoy to extend and have custom whatever you want to do with Envoy. It's a proxy that is a sidecar on application. So the possibilities of what you can do are limitless. With this WASM extensions, you can pretty much do whatever you want on the proxy level. I would of course suggest going with Rust SDK, because Rust has the best ecosystem when it comes to WebAssembly. Not just because I like Rust, it has the best. No, it seriously has the best ecosystem for WebAssembly, and it's quite straightforward and extremely nice ecosystem. So yeah, so this is how you would extend Istio further. And finally, if you did follow along, don't forget to delete this cluster. Last time I forgot to delete, and after a month I got like $200 or something as a bill. Then I deleted it. So I have to remember to do this now. So yeah, so finally, so is the Istio mesh worth it, right? Of course, there are a lot of pros and cons. A service mesh provides building blocks to build distributed microservices in a more Kubernetes native way. So it takes the complexity and responsibility of maintaining all these infrastructure away from you, right? This means you do not have to worry about maintaining the code or deployments for service discovery, tracing, and all that. You get all this from the platform itself. And we are definitely, as an industry, we are moving towards a future where only code we want to write is business logic, and we are using other tools and services to fill all other aspects of the architecture, right? And this is evident from the rise of low-code platforms these days. And with JHipster, we were at the low-code scene way before low-code was even a thing. So with tools like JHipster and Istio, you are reducing the amount of code that you would have to write and maintain yourself, and you're pushing that into platforms. So this Istio is also part of that kind of feature. So while a service mesh is nice, it's also not a silver bullet, because it is quite complex software, and debugging Istio locally is very challenging compared to a traditional application. There are ways to debug with all this telemetry stuff. You get some help, but it's still much more difficult to debug it locally. Running it locally is also a bit more challenging. Another thing to keep in mind is resource requirements. So the same microservice setup that I used here can be deployed to a 2-node cluster with the basic virtual CPU and like 3.75 GB of RAM on GCP. It will work. But if I try to install this on the same cluster, there is not enough resources. So I need a bigger cluster with a bigger CPU and RAM in order to run all this. Of course, that is also because I'm using the demo profile where there are no request limits set on anything. All the Istio stuff just uses as much as it needs. By tweaking that and fine-tuning that, you can bring that down. So probably you can bring it down to a 3-node cluster, but still you need more resources than a normal cluster, because you have to run sidecars along with your applications. You have to run the Istio daemon. You have to run all these monitoring stuff. So you need more resources than a traditional architecture. And that is the give and take. So in a real-world use case, the advantages of not having to maintain your own infrastructure, you will consider that along with the cost of running slightly more, paying slightly more to your provider for the additional resources. So you'll kind of weight that and you'll choose, okay, what do you care about more? If you care about maintainability and stuff like that, then yeah, go with the additional stuff. But if you care about cost, then yeah, maybe not. So that's how you would kind of make decisions here. And finally, so you can get the slides I used from this QR code. So take a pic or whatever. If you, I'll also tweet the links to the slide on my Twitter. So that's it, I think. If you have any questions, please come to me. I'll stay around somewhere here for a while. Come to me. I'll be happy to talk about that. And thank you very much for spending 3 hours of your valuable time with me. I appreciate that. I hope this was useful at some level. So thank you, everyone.